In item number 4, we have another truss, and we're asked just to find one member force, this time BG, so let's mark that one. And, okay, I only have one. I'd like to try to do this without having to do any calculation of the reactions. Let's see if that might be possible. A free body diagram might we be able to do that will get this done in the fewest steps possible. And I could do method of joints, but gee, it sure looks like I'd have to feed through a bunch to get there. Or if I go this way, I have to find reactants. Yuck. So rather than do it that way, I think maybe it might behoove me to do method of sections instead of joints. Cut all the way through the structure, including the member that I care about. And then let's get this drawn out. Some sort of approximate scale. Let's see, that might look like that, and then there we go. There's the truss. Here's the applied load of 15 at D. I think maybe the top chord in this case will be in tension. That would be BC. And I think the bottom chord might be in compression. That would be FG. And then the one I want is BG. And I look at that and I say, let me see if there's a common place where forces intersect. Well, two of them intersect at point B, but hey, that's got BG. That's the one I want. Although that would be useful if I wanted to know FG. Yeah, I don't want that. If I sum forces in the Y, I don't know FG. I know now how to find it, but that's two steps. I can sum forces, and that'd be carryover. Hey, wait a minute. What if I look at where the top chord and the bottom chord intersect? That gets rid of two unknowns, and that also, well, that's bizarre. That asks where the point load is. Let's write out equilibrium here. And I think we just found a zero force member is what I think. And that's kind of interesting. Whoever designed this test was being sneaky. Alright, so if we sum moments about point D, let's take clockwise is positive. Moment arm is 24 for BG. It's entirely vertical it is. And there's nothing else to show up in that equation. Therefore, BG must be a zero force member right now. Wow, he didn't tell us to identify zero force members, so maybe there's a trick. Maybe that was a mistake. But there's got to be another way to do this. Alright, well, I remember when we were looking at zero force members that we would go look for slanted T-joints. That means three forces that two of them collinear. Not here. That's we've got 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 forces there. 1, 2, 3, but they're not collinear. 1, 2, 3, 4, not collinear. 1, 2, 3, 4, not collinear. No. Right? 1, 2, 3, 4, not collinear. 1, 2, 3 forces not collinear. 1, 2, 3. Ah! Hold on a second. Joint H has got 2 collinear forces. Third one has got to be 0. It's a vertical forces. In this case, some forces, that'd be CH, and some forces in the Y, and I'd only have, oh no, I don't want Y, because these got Y components. But if I do it Y prime, those two don't have any Y prime components. I only have CHY prime, that has to equal 0. Therefore, CH equals 0. Alright, so follow this to the other end. Go look at joint C. I'm starting to feel like the math we did before in one step was dead on right. Now when I go up there, I've got the zero force member CH, nothing. I've got then the CG, and I'll assume that's in tension, but look what's going to happen. Some forces this time in the Y. The only thing left over is going to be CGY prime, and that's got to be equal to 0, so therefore the whole thing is equal to 0, and that means when we go down to joint G, Now that simplifies that joint a lot. And there again, there's a y prime, there's the force PG that we're after. CG was 0, and so some forces in the y prime is going to be BG y prime has to be equal to 0, so therefore BG equals to 0. That was a 3-step procedure to verify what we had already discovered, that BG is a 0 force member. Right now, if you've got a professor who's very particular about these things, well, maybe we need to show the other member forces in here for a complete free body diagram. Get those last few little points. Looks like everything's good. And bam, we have scored.